Let's welcome Vuenion.
Hello. Wow, here we are again. Yeah, I'm super excited to be here again. Last year when I was here, it's like, how am I supposed to speak under this screen? But still feels pretty amazing this year. So again, thanks everyone for coming. It's really awesome to have all of you guys here with me. And today I'm going to be talking about State of the Union, just a bunch of updates on what we did in the past year, what we just recently released, and what we're planning to do for 2019. I already talked quite a bit about 3.0 in the last few talks I gave in the past few months, but most of them have been focused on specifically on 3.0 and the technical details. And this one is going to be looking a bit more on the big picture of why we're doing what we're doing for 3.0 and some of the organizational aspects of how we're planning to scale the project even more. All right, so let's get started. Looking back at 2018, we didn't do too much on Vue Core in 2018. We've mostly been focusing on the tooling aspect. I actually spent quite a bit of time on Vue Press. That started out as when I was trying to rewrite some of the documentation, and I realized our usage of Git back then was just leaves so much to be desired. And I decided to, the typical process of a developer trying to write a blog, then you realize, oh, I want to do a customized theme. Then you want to do a customized blocking system, and you end up building your own static site generator. That's exactly what happened to me. And that's how VuePress kind of came along. And now it's powering most of our sub-project documentation. And Vue CI 3 obviously was probably the biggest release for us back in 2018. We really tried to standardize the tool chain and try to provide a system that people can extend, but at the same time, we try to hide as much as possible so that if you just want a tool chain that have a sensible default, you can just get started running as fast as possible. Then we started really starting to look at 3.0 and thinking about what we want to do for the next major version. We did a lot of research and prototyping. It's still work in progress, but I think we found we've already made a lot of interesting discoveries and validated a bunch of ideas. And actually, a lot of these things that we plan to do will consolidate, and we'll post them as public RFCs very soon. So stay tuned for that. 2.6, which we just released this month, actually. The majority chunk of the work was actually done back in 2018, but it really, when you try to release something, orchestration and documentation and all the extra work really piles up, and we ended up releasing in 2019. But a lot of good stuff in 2.6, and we'll talk a bit about that later. So usage statistics, I try to, every year when you look at talks from, say, WWDC, you see Tim Cook get up there, and then he started bragging about how many units of iPhones we sold in the past, how many, we are like, our revenue numbers grow. But for Vue, I don't really view it as something that, we're not really chasing for aggressive growth. That is not our primary goal, right? Stats is really just a metrics that we use to gauge a relative status of the ecosystem and think about what we should do next. We don't want to say only focus on growth, because that is not our goal. If there is an objective statistic about how happy our developers are, that's what we want to focus on. But nevertheless, if you're still interested in numbers, we currently have around 700,000 weekly active users of our dev tools. Over 3 million downloads per month on NPM. And I was thinking about that because, our downloads on NPM isn't fully representative of how many people are actually using it, because one of the unique advantage of Vue is you can really just link it from a CDN, and it actually can work, right, in production as well. So I just briefly checked out how many downloads, how many hits we get on JS Deliver, the CDN, and turns out we have over 461 million hits per month. That is quite huge, and I don't even know how to compare that in scale. Okay, so I checked it up. jQuery has like around 900 million, so we're like half where jQuery is. I mean, jQuery is still huge, so pretty proud of that, actually. So latest release was 2.6, right? Macross. For those of you who are not into Japanese anime and stuff, you should look it up. It's pretty good. And if you have been checking out our past release code names, you'll notice there's a pattern. So you're welcome to place a bet on what the next one is. Anyway, one of the most important things we introduced in 2.6 is the new slot syntax. We had an RFC for it, and we'll talk a bit about more in details. It also comes with improved asynchronous error handling. So if you use async functions for your lifecycle hooks, those errors during all this async process will actually be captured by Vue's error handlers now. So you'll be able to more easily handle all these async errors, send it to your error statistics services. We have improved compiler error messages. So now if you make a syntax error in your template and the compiler complains, you actually get a code frame that points to exactly where you made the mistake. This is actually thanks to a very impressive pull request from a community member. And he submitted a long time ago, but I really have to apologize to him for waiting so long before merging this, because this is such an impressive pull request. And then we have built-in data prefetch support during server-side rendering. So this is pretty important for all the server-side rendering solutions, because up until now, when you try to prefetch data on the server, they're coupled to your routing system. When you visit a route, you have to place your data fetch logic right in the top-level route component, right in the route component for that specific route. Otherwise, they will be skipped. This places an unnecessary restriction on where your data fetch logic can be placed at, right? So in 2.6, we give you the ability to actually place that logic anywhere down your component tree. And this greatly simplifies the implementation for higher-level solutions for server-side rendering. For example, Vue Apollo now can essentially allow you to prefetch GraphQL data anywhere inside your application, and Nuxt will be able to leverage this to greatly simplify its async data implementation and remove some restrictions. So overall, this will result in better development experience for server-side rendering apps. Okay, so the new slot syntax, it has an RFC, which is request for comments. It's a process we just recently adopted that requires us to go through a public request for comments process before we land substantial changes in Vue. So this is a significant process change, because in the past, a lot of times when we land some changes, most of our users don't find out until the release actually lands. But now, before anything actually takes shape, we require us to post the proposal to the RFC and solicit public feedback. So everyone has a chance to give us their feedback on what they think about the new syntax, so we can adjust accordingly before we actually land the change. And it's really helpful, because it helps us consider things we may have neglected. It helps us discover edge cases. It helps us better gauge the potential impact on existing use cases when we introduce something new. And this overall brings better stability to the framework as a whole. So the major advantage of the new syntax, first, is it offers more succinct usage for default scope slots. In the past, you have to this is probably the most common usage when you're trying to use scope slots for components, renderless components that encapsulates logic and primarily leave the actual rendering the content to the consuming component. And when you have only a default scope slot, the new syntax gives you a much more succinct usage. And when you use named slots, so the new syntax actually unifies normal slots and scope slots under the same syntax. And when you use named slots, it actually gets a little bit more verbose, but that's intentional because you want to enforce a more consistent and more explicit overall usage for named slots. In the past, you can either use template wrappers for slots, or you can omit them. And when you mix these two together, and also in the past, you can essentially have multiple elements and give them the same slot name, and they'll be implicitly grouped into the same slot. So overall, we find that although it's really flexible, but oftentimes it actually results in, depends on how people prefer to write it, we result in a lot of different ways of writing slots. So the new syntax intentionally sort of forces everyone to use the same style, and overall should result in more consistent and readable templates. And finally, it's easier to associate slot scope declarations with the component providing the scope. So this is a bit more abstract and hard to explain in the talk, so I encourage you to just check out the RFC to see what we really mean. The RFC really explains this problem in details. So, and then I want to talk a bit about normal versus scoped slots. So how many of you have actually used scoped slots? So not a very high percentage. So scope slots compared to normal slots, the advantage is scope slots allows you to, the difference between normal and scope slots is illustrated here, right? If you think about our templates as when they are compiled into JavaScript, normal slots is about passing some child elements into a child component. Here we are creating a component foo, and we're passing a div into it as its children. And this gets processed as a normal default slot, right? This default slot depends on this .message. In the normal slot case, this slot content depends on this .message. So whenever this .message changes, this is supposed to re-render and update, right? But because here, this slot content is evaluated before this foo is created. This is evaluated first, right? So this .message gets registered as a dependency of this whole parent component. So whenever this .message changes, this parent component needs to first update, which then results in this being created again, then passed into the child component, which then forces the child component to update too. So the parent and child have to both update in order for a slot to be updated properly. In comparison, a scoped slot, when compiled, becomes a function, right? The difference between passing an expression directly down versus passing a function down is the function can be called lazily. When this whole expression is executed, the function is only declared, but it's not called yet. It's called lazily after it's being passed to the child. So the child gets to call it during the child's own rendering cycle, which means this .message is registered as a dependency by the child now. So when it changes, it only causes the child to directly re-render. It doesn't affect the parent anymore. So now, when this .message changes, we are only updating one component instead of two. And imagine this whole update, this whole optimization when you apply to a huge application that uses slots all over the place, right? So we are reducing a lot of unnecessary updates simply by turning these slots into functions. And this is the performance advantage that scope slots offers. And in 2.6, we introduced a bunch of optimizations to overall make the updates as accurate as possible. So when a child component only uses scope slots, it typically achieves a really good separation between parent and child. So there's very few cases where both of them have to update at the same time. So overall, when you have a huge component tree and you update your data here and there, usually you get the most accurate number of components that gets triggered to update. In comparison, if you use normal slots, it's very possible that when you change something, because of the parent-child slot relationships, you are actually triggering multiple components to update at the same time with a single mutation. So our goal in 3.0 is to make all slots implicitly scoped. So the syntax-wise, this is also one of the reasons why we're unifying the two types of slots under the same syntax with the new slot syntax. So that means whenever you use the new slot syntax, all of the slots are actually internally compiled as scoped slots as well. So if you're using 2.6 and you're already using the new slot syntax, you're actually already getting the benefits of these performance improvements. And in 3.0, we're just completely removing the concept difference between scope versus non-scope slots. It's all just slots, and they're all functions, and they all get the same performance benefits. Okay, so these are the technical details of what we've just released. And this, and as you can see, this is actually a step that we're trying to align our 2.x release, which is completely backwards compatible, and you can use it today, but we're trying to align it towards what we're planning to do in 3.0. And we plan to do for most of these major changes we're trying to introduce. We want to ship whatever we can that is backwards compatible in 2.x before 3.0 arrives. And so by the time it actually hits, you're a lot of you may already have been using these new features for a while, and it makes a lot easier for you to migrate to the proper 3.0 proper. All right, so let's take a step back and jump out of the technical aspect and look at the big picture. Right? So instead of focusing on what specifically we've done, I want to think a bit about, so Vue as a project as a whole, how do we keep it moving forward, and how do we keep it, make sure it stays relevant, it stays strong, and stays competitive for the long run. Right? So there are two aspects of this. One aspect, obviously, is technical. Right? There are new standards, new features, new language features, platform features coming out. There are new patterns emerging, and we want to take advantage of these new features. We want to keep up to date with whatever new pattern that is emerging, and these are important to keep the core framework up to date and competitive. And there are the organizational part. As a project, as a group of people working on a project, how do we scale it? How do we make people work on it more efficient, and how do we make people who want to work on it, how do we make the work sustainable, and how do we make the project itself more reliable and make people who want to adopt it find it easier to make the decision? So these are all the things we want to consider. So the technical direction overall is, especially in 3.0, is we want to align with what's coming up in the future. And there are a bunch of things we want to consider. First is language, the language itself. Vue.js, right, it's JavaScript. JavaScript is evolving, so any framework built on top of JavaScript has to evolve with it. And we're seeing ES2015 being natively available in almost all evergreen browsers now. If you check the compatibility table, right, Edge, Firefox, Chrome, Safari, pretty much already has baseline support for ES2015 if you're on the latest, right? It's unfortunate that if you have to support older browsers, but in the foreseeable future, right, baseline ES2015 support will become something that is native in a majority of your user base. So it makes sense to start thinking about how to leverage these new features. So for Vue, in Vue Core, obviously, 3.0 leverages proxies for change detection. We're also shipping a native class API. So this is as we mentioned in the post, it's going to be simultaneously supported. So that's added on top of the object-based API. And it's pretty much just making the Vue class component a first-class citizen of the framework. And because we're leveraging native classes, it's actually really lightweight to add that support. And we're only we're intentionally designing the class API to only use the features that have shipped in browsers. So the latest stable version of Chrome 72 actually already ships with class fields. Although it's only stage 3, but it has shipped because most of the controversial parts have been settled in the standards discussion. So it's considered relatively stable now. So our new class-based API will leverage native class fields, and that's pretty much it. We're intentionally doing away with decorators for now because its future is still in uncertainty. Decorators it actually went through a major revision, completely changed, and they're trying to advance to stage 3, but it got rejected in the latest TC39 meetings. So it's actually still kind of risky to rely on decorators. So we're intentionally designing the API without decorators and waiting to see how it eventually shapes up. ES modules top-level API for tree shaking. So interestingly, ES modules, when we introduced ES modules, because it's statically analyzable, So this is important characteristics of ES modules, which allows all the tree shaking to be possible. And one of the issues with our current 2.x global API is everything is attached to the Vue global. This means when you import Vue as this magical object, right? It contains every runtime feature that we are shipping. So when you import Vue, you're accidentally also importing a bunch of things you may not end up using in your final application. So in 3.0, we want to restructure our global API so that you only import specifically what you're using. Obviously, this is to a degree where it doesn't become super cumbersome. An example of that would be, for example, the transition API, right? You don't have to manually import it yourself. The compiler actually does it for you. So when you use the transition component in your template, the compiler output implicitly imports the transition component from Vue internals, and it gets included in your final bundle. But if you don't use the transition component, then it never gets imported. So it can be tree shaken from your final output. So this all happens under the hood. You don't even need to worry about it. And for the explicit APIs that we intend to make them importable, we'll open RFCs for those. And then map sets, weak maps, these are really, really helpful data structures that can greatly simplify our internal implementations, where we often have to resort to custom polyfills or hacks, or less efficient ways to keep track of things. So overall, ES2015 has allowed us to implement a Vue core that is leaner, faster, and overall a great improvement of quality of life improvement for us maintainers as well. ES2015 and the CLI integration mostly comes at how do we selectively ship native ES2015 in supported browsers? Because, as we mentioned, there are a significant chunk of our users are already on browsers that natively support ES2015. And when you transpile code, the transpile code is less efficient because it uses all these extra ES5 code to achieve the equivalent of what native code does. And native code is usually better optimized in the engine, and it gets even better optimized in the future. So you want to start shipping native ES2015 to the browser that already support it. And that's exactly what modern mode in the CLI allows you to do. So it automatically builds the two bundles, one targeting modern browsers and one targeting legacy browsers, and then it generates the HTML that automatically falls back to the legacy bundle only when it detects that the browser does not support it. And Vuex, right? We have some plans to redesign Vuex API. You can already use async await for your actions, but So when we were doing that for a while, we realized that if you're already using async await, then we can further simplify the concepts by just getting rid of mutations so that you don't have to, when you try to do the one thing, you don't have to like first do an action, then a mutation, then eventually achieve the simple thing that you want to do. With async await, the intention is quite clear, and our dev tools can leverage the promise to detect the start and end of an action. So we want to simplify the concepts by potentially just merging the two concepts, and that requires us to update the dev tools, better display the asynchronous flow of actions. But we're already discussing how to do that. Class-based API for the stores is something that's further off the roadmap, but one of the pain points currently using Vuex is if you use TypeScript, it's pretty hard to do type checking for Vuex stores, and we want to make that easier with a better API, a more type-friendly API. ES2015 with a router, so code splitting, right? If you do code splitting with a router, currently with Webpack, you can just do a dynamic import, and that Webpack internally translates it into an async AJAX request that fetches the chunk that corresponds to it. But our code splitting implementation is actually implementation agnostic. So even if the code is not transpiled by Webpack, even if it's actually using native dynamic imports in the browsers, it already works with our routers. So which means in the future, when more browsers support native dynamic imports, you can just leverage the native imports for code splitting. And hopefully, I hope that Webpack can eventually allow us to, Webpack should offer a modern mode that just like gets rid of all the runtime requirements to polyfill to fake the dynamic imports. Instead, it just emits chunks that uses real native dynamic imports. Okay, so a bit about TypeScript. So how many of you use TypeScript? Actually, a decent number, more than I thought. But TypeScript has really gained some momentum recently, and Vue's current story of integration with TypeScript is definitely not as strong as, say, React or Angular. Most of the reason being when Vue 2 was initially designed, TypeScript wasn't as popular as it is today, and also this overall recognition of the need for type checking in front end wasn't as prevalent as today. So I think one of the reasons is more people actually need to build larger scale applications, and there's an influx of more people with experience in static type checking languages coming into front end as well. So we do acknowledge that this increasing importance of TypeScript. We're not saying that it should be the one way to build applications, because non-TypeScript use cases is still the baseline and the core of Vue's overall use range. But we do want to offer good support for those who want to use TypeScript with Vue. So Class API is one of the most straightforward way to offer better type inference when you use TypeScript with Vue. And then TSX support is something that people coming from switching from React to Vue kind of really wants. Then we're also aiming for better IDE support, because TypeScript is actually, in addition to type checking, it offers a pretty good infrastructure for doing IntelliSense, autocomplete, figuring out what values are valid in a certain case, right? So when you combine that with a good IDE support, that's a very good development experience. And want to leverage that, and want to extend that to templates as well. So we are actually working with the author of Vater, who is on the VS Code team. He actually got permission to spend a few months to help us figure out a good story of better template IntelliSense support in VS Code. And that should result in even better development experience overall. And then we want to upgrade our correlates and plugin patterns with type integration in mind. Okay, so I think I need to move a bit faster now. So Most importantly about TypeScript is being TypeScript friendly doesn't affect non-TS users' experience. That's the requirement for anything we do with TypeScript. So if you don't use TypeScript or you don't plan to use it, so there's nothing you need to worry about. The API is going to work pretty much the same with or without TypeScript. And if you do end up using TypeScript, the good news is you get better support. Right? So our internal implementation is also switching to TypeScript. So we already use a type system. We use the flow since the start of 2.x. And turns out TS is doing much better than flow now. And switch to TS is mostly an internal implementation detail. It doesn't affect how you consume Vue's API from user land. It does increase the contribution barrier a little bit, but we believe it will pay huge dividends in the long run because having a TypeScript type system really helps when you're refactoring a code base and you're maintaining it over a really long time. Okay, web components. Short conclusion is, I believe in its current state, web components is most valuable as a distribution or interop mechanism. I don't see a strong case for, say, making every component in a framework a custom element. And Vue Core has always been friendly for consuming web components, which is what makes Ionic 4 possible. So Ionic 4 is rebuilt using web components, and you can easily use Vue with Ionic 4. So that's made possible because they are shipping as web components, and Vue is good at consuming web components. Right? So our CLI also supports you to build Vue components and ship them as native web components. One of the possible good use case for native web components is Shadow DOM that offers natively scoped CSS. But this is not very server-side rendering friendly because you don't actually get declarative Shadow DOM, which is to say, Shadow DOM only expands at runtime by JavaScript. So when you render it on the server, you only get an unexpanded custom element tag, which is pretty awkward. And there isn't a perfect story for this, so which is also a big blocker for major frameworks to consider using native custom elements. HTML modules is actually a possible, very interesting twist. It's technically part of under the web components umbrella, but it essentially allows browsers to natively import a piece of HTML like a JavaScript module. Pretty much what we're doing with single file components in Vue, right? In Vue applications, you import a Vue file as a JavaScript module, as a component. So HTML modules allows you to do that natively by importing an HTML file as a JavaScript module, and that exposes the JavaScript inside that HTML file along with the document of that HTML. So with some modifications, we can possibly achieve something that is really close to a native single file component experience, and that's going to be really good for beginners, for introduction, prototyping. We're still investigating the viability of using it for production, but for now, it seems a very interesting development in overall the story between Vue and web components. And the Edge team already shipped an intent to implement for this in Chromium. So if you're interested, you should keep an eye on that. WebAssembly, too long didn't read is WebAssembly is good for intensive computation work, offloading that off the main thread. But it's not quite suitable for the type of work UI frameworks typically do. So UI frameworks typically do a lot of we need to do a lot of frequent, small chunk of work. And we also have to access the DOM very, very frequently. So this is not the type of work that would benefit a lot from WebAssembly. And actually, if you use WebAssembly to, say, process your pure JavaScript work and then send the payload back and forth between the main thread in order to touch the DOM, it actually leads to a lot of communication costs because you're always like serializing a lot of data, send it to the WebAssembly thread, then send the data back in order to touch the DOM. So this communication cost kind of outweighs the benefits you actually get from it. And then there's additional distribution cost complexity involved with WebAssembly. So, but it could be potentially useful in server-side rendering, something that we would be interested in investigating, and it could result in huge performance swings. Mobile apps, we have a first-class custom renderer API. We already have solutions like NativeScript Vue or Weeks, but currently they have to fork Vue internals, and that places the maintenance burden on them, and want to make it easier for them to do their jobs. So 3.0 with a custom renderer API will allow them to much more easily create custom renderers and also open up possibilities for, say, a custom test renderer, rendering Vue to the terminal, to canvas, to whatever you want. These are technically already possible, but 3.0 will make it so easier that anybody can do it. You also have maturing Cordova-based solutions like Quasar, Ionic 4, Onston UI, which I already mentioned. Quasar just released their 1.0 beta, which is really impressive. I encourage everyone to check them out. And smarter work scheduling. So this is largely inspired by React Fiber and the type of thing that they're doing with time slicing. So I demoed a while back that we already got time slicing working in the Vue 3 prototype, and we're further trying to investigate how we can make it more stable and potentially leverage the same mechanism for pre-rendering components in low priority mode. And this can have a lot of use cases. For example, we just recently got a feature request saying, when you have a keep alive component with multiple pages inside of it, is it possible to say, pre-render some of the other pages and then keep them alive? So this way, when users switch to it, the page is already loaded, and they don't have to wait for a lot of JavaScript to process before they can see the page. And this requires us to be able to pre-render the page in low priority mode, which means it should not block user interaction on the current page when it shouldn't. So this is some interesting areas to explore. New patterns, React hooks. Sarah Drasner, who unfortunately cannot be here, she wrote a pretty good post on what hooks are and how they could potentially be used in Vue. And the overall idea is there are some really interesting things about hooks that we want to leverage. Mostly it's about logic reuse and composition. We're most likely not going to have a verbatim same kind of hook API in Vue because the whole functional approach is not what idiomatic Vue usage look like. We want to have something that fit in with Vue's own idiomatic usage, leverage Vue's reactivity system, and avoid some of the closure-related confusion in React's hook implementation. Overall, it's something we're still exploring, but I think we will have something interesting to present later this year. Okay, so I'm already over time, so I have to kind of rush through this. There are a lot of organizational things we want to do to help scale the project further. First is the RFC process. I already talked about this a bit. If you are interested in keeping up with what's going to land in Vue, you should definitely follow this repository. This is where all major changes that's going to happen in the future is going to land. And every major breaking change for 3.0 is going to have an RFC, and everything that potentially changes the way you do things is going to be discussed here first. And if you have ideas of how to improve Vue, you're more than welcome to submit RFCs as well. So this is open to anyone, not just to core team members. Operation guidelines. So this is just, we just got started with this, but this is a place where we intend to place all the documentation on the operation side of the project. Like, how are you supposed to run the tests, manage the CI, triage issues, cut releases? So pretty much like what core team members do on a daily basis, so that anyone can just read these and understand how we're supposed to run the project, so you can just step up and help out with some of these, and maybe you'll become a core team member. Sustainability. So a shout out to Modus Create. They just recently gave us a $25,000 donation on Open Collective, and they plan to do that for each quarter throughout the year. So this is enough for us to fund a full-time work by additional team members. So Sodati, if you are using CLI and keeping track of its issues, he's actually been working full-time on Vue CLI for a while now, and is now funded completely by through Open Collective. And Guillaume Acrium is his handle. Guillaume, who's going to talk after me, he also has part of his work sponsored through Open Collective. And he works on various projects in the Vue ecosystem. Also, more core team members are starting their own Patreons. If you feel that any of them are particularly helpful to the things you're doing, please consider donating. And we also want to, overall, the project wants to find a more direct way of supporting our core team members to spend more time on Vue, which we'll discuss a bit later, something we're considering. So I'll kind of keep that vague for now, because we're not completely sure how it's going to turn out. But I think long-term sustainability-wise, we're going to have to do something interesting. OK, I'm going way over time, but bear with me. More structured minor release cycles. So after 2.6, we're going to move every 3 months. And potential commercial support offering, this is something we are thinking about, because I've actually talked to a few companies, and our management doesn't feel comfortable adopting a project without paying for it. I'm like, OK, if you want to pay money, we'll probably figure out a way for you to do that. And the path to 3.0, as I said, so we don't have a definitive date. All breaking changes go through RFCs. Most compatible changes will land in 2.x first. Documentation will receive a major overhaul. We want to improve it, and update it to reflect what's new in 3.0. And finally, there will be migration tools, guides, code mods, and compatibility adapters to make sure you have a smooth experience going to 3.0. And that's hopefully going to happen later this year. So our roadmap indicates that we plan to have something that is publicly testable by end of Q2. I think that's feasible, but again, it's not set in stone. So if we miss that, it's ready when it's ready. We want to focus on delivering good work instead of just hitting a specific date. So yeah, that's pretty much it for today, and thank you.